Hello, everyone, and welcome. Thank you for joining us today. My name is Emily Summars-Jeffries, and I'll be your host today. We'll be talking to scientists from the Cooperative Institute for Mesoscale Meteorological Studies at the University of Oklahoma. We are here to talk everything from what inspired our scientists enter the field to what they're doing today. We're really excited you joined us, and thank you. Oklahoma is still experiencing some power outages from a recent ice storm. And so, unfortunately, because of that, we may lose some panelists just due to power connectivity and Wi-Fi issues. If that happens, and you have a question for them, please send it to us and we will put that information in the chat so you can see it and let you know if that becomes an issue. So now let's meet the panelists. First off, we have Alyssa Sockol. Alyssa, thank you for joining us. Oh, Alyssa, for some reason, we can't hear you.
Okay, can you hear me now? Yes? Okay, good. I am Alyssa Sockol, and I'm a research associate with CIMMS. I support the ARM Data Quality Office, and ARM stands for Atmospheric Radiation Measurement User Facility.
All right, thank you. Next, we have David Schvartzman. David, please introduce yourself and thank you for joining.
Thank you, Emily, for that introduction. Hi, everyone. I'm David Schvartzman. I'm a research associate at CIMMS, and my work supports the NOAA National Severe Storms Laboratory. I work at the Advanced Radar Techniques team, developing radar engineering techniques for future and current weather radars.
Thank you, David. And last but not least, we have Hannah Wells. Thank you, Hannah, for joining us.
Thanks, Emily. Like Emily said, my name is Hannah, and I work as a research associate with CIMMS, and I support the National Weather Service Warning Decision Training Division.
Thank you very much. All right, and as I said before, we will be taking questions during this panel. You should see a header on your sidebar that says questions. At any point during this meeting, please submit your questions in writing in the questions pane of GoToWebinar. We will collect them throughout the meeting and answer as many as we can during this process. You can submit questions for everyone on the panel or any specific person. Just know that no question is a stupid question or an impossible question, and we will try to answer it, and just don't be hesitant at all. So let's go ahead and get started. So we will kick off our panel with Hannah. Hannah, could you tell us a little bit about what you do, please?
Yeah, so at the Warning Decision Training Division, we are the branch of the National Weather Service that teaches National Weather Service forecasters how to issue weather warnings. So I help create and develop training on how to teach forecasters how to issue severe thunderstorm warnings, tornado warnings, flash flood warnings, winter weather warnings, and I also work on training and working more of like how to maintain situational awareness while you are working a weather event, how to maintain proper staffing during a high impact weather event, and some of the more human side of forecasting and not just the science side of issuing warnings. So that's what I do.
Well, thank you. And I want to add that Hannah and her process with the Warning Decision Training Division, they see every forecaster from National Weather Service in their process. So every forecaster from the Weather Service gets trained within their entity. So I know Hannah's got a few great stories and great experiences, and we appreciate what she does for the forecasters. So thank you. Next off, we will speak with David. So David, can you tell us a little bit about what you do, please?
Yeah, absolutely. As I said before, I work at the Advanced Radar Techniques team. our main focus is to develop new radar signal processing and scanning techniques. In particular, in the team, my role is to look at new techniques for future weather radars. We want to investigate potential technologies, that could be better for future radars for the whole country, and that ultimately will improve the data quality that we give forecasters and automatic algorithms that look at this data. Our ultimate goal is support their decision-making process for issuing warnings and forecasts. That's one of the main things I do. And then on the other hand, I also work developing signal processing algorithms for the current weather radar network, the Weather Surveillance Radar 88D, which is operational in the whole US.
Thank you. And as you said, that radar network is operational throughout the United States, the one that you help continue to support and work on algorithms that help them continue to improve it and make sure it stays up to date. And for those of us who are seeing storms, that is where we receive our most up-to-date information right now. But on top of that, you are also making sure that we are continuing to work on the latest and greatest. And so we appreciate that as well. And now, Alyssa, could you please tell us a little bit about what you do?
Sure. So as I said, I work with the ARM Data Quality Office, and it's the Data Quality Office's job to keep an eye on all of ARM's weather and climate data to make sure that it's of good quality. A lot of meteorologists often use weather data in their research, so it's important that the data that we provide them is accurate and reliable. ARM operates almost 200 weather instruments located all over the world that collect weather data at the same time. And so we write computer code that takes the data collected from the instruments and create graphs and pictures that we can look at from our own computers, which makes it easy to figure out when a weather instrument is broken and therefore might not be collecting correct data, and if the instrument needs to be fixed.
Thank you. And I know that you have quite a few interesting stories about animals and how they can impact those instruments and data collection. And so I always enjoy hearing those, and hopefully we can get into some of that in the panel. If not, I know you recently did a video, and that is on the CIMMS YouTube page. And so those are interesting. So we'll go back to David real quick. Was there a specific moment that inspired your interest in weather and kind of that ongoing love you have with radar?
Well, yeah, I think it took me some time to realize that what I wanted to do was get into weather radar. And let me tell you a little bit about that story. So I graduated with a bachelor's in electrical engineering, and the emphasis was on telecommunications. So right after graduating, I started working as a telecom engineer, and I worked as a telecom engineer for a couple of years. And when I was working for telecom, I realized that I wanted to do something that would help society somehow, more than just providing cell phone service and things like that. And so I started thinking, well, I like antennas, I like signal processing, I like all these things. What would be an instrument or a way that I could relate my expertise in trying to help people? And so I thought, well, one thing I could do is look at weather radars. And I always also just had a passion for nature and how nature works. And so, I started talking to some scientists here in CIMMS, and that really piqued my interest in weather radar. And so I got into it, and before I knew, I was fully into weather radars and developing signal processing techniques. So that's when I discovered that was my passion.
Well, thank you. We appreciate you sharing that. And Alyssa, what about you? Was there a specific moment that inspired you to get into weather and into your field?
For me, there wasn't necessarily one specific moment, but I think growing up in Chicago with all of its weather extremes definitely helped influence me to get into meteorology. But for me personally, there wasn't one specific moment.
And I know as we've heard, Chicago has some intense winds. And so that was, I'm sure, very influential. And Hannah, oh, go ahead.
I just said yes. I
Yes.
agree.
And Hannah, what about yourself? Do you have a specific story for us?
Yeah, like Alyssa, I don't really have a specific moment that I at least remember. But as I got older, my grandma would always tell me that when her and my grandpa would come to visit us when I was like 4 or 5 years old and we would drive somewhere, I'd always look out the window and like point out all the clouds and tell my grandma about what kind of clouds they were, when I was in kindergarten. So clearly that love of weather was something that happened when I was young.
I think that's the way it is for some people, and I think that is great. I'm sure your grandparents enjoyed that time and enjoyed that. So, Alyssa, how did you get to where you are today with CIMMS and supporting the ARM Data Quality Office? Can you tell us a little bit about that journey?
Sure. Right out of high school, I had no idea what I wanted to do, but I knew that I liked the weather. My undergrad, unfortunately, didn't offer meteorology as a major, but they did offer earth science. And as an 18-year-old, I thought that sounded like the closest that I could get to meteorology, so I went with that. I knew that I could go to grad school for meteorology later on, so while I was an undergrad, I took a bunch of extra math and physics classes to prepare me for grad school. And then I started to apply my senior year, and I was then accepted into grad school, and I ended up with a master's in atmospheric science, and I was able to start applying to any weather-related jobs that interested me after that.
Well, very nice. And I know that you mentioned your application process. How did you choose kind of the schools of where you wanted to go? I know that we shared a picture on social media and you were in Hawaii. Can you kind of tell me about that?
I think that I Googled which schools had meteorology or atmospheric science as a major for grad school, and I applied to 5, I believe, and I got into a few of them. Hawaii was the only one that offered me a research assistantship, so it seemed like sort of a no-brainer at that point that I was going to go to Hawaii. And when I actually got to Hawaii and started, their master's degree was in meteorology, but then they decided that they wanted to change the name to atmospheric science. And because I started when it was meteorology, I got to decide whether I wanted my degree to say meteorology or atmospheric science. And I ended up going with atmospheric science because I felt like that was a more generic, broader, all-encompassing major that would, I think, resonate with more jobs that I was looking to get. So that's what I went with.
Well, thank you. I appreciate that. And Hannah, what about you? Kind of how did you get where you are today?
So mine's pretty similar to Alyssa. I went to college right after I finished high school. I got my bachelor's degree in meteorology, and then I went to graduate school and got my master's degree in geography from a school that had an atmospheric science program within the geography department. And then when I finished my master's degree, I started applying for jobs and got a job at CIMMS with the Warning Decision Training Division.
And can I ask, how did you specifically, I guess, why did you choose forecaster training with the Warning Decision Training Division?
I felt that it fit a lot of the skills that I have and what I like to do. While I love meteorology, I don't super love being the person who does the forecasting. And I have a lot of experience with teaching outside of meteorology. Like I was a dance teacher in high school and off and on in college. And I've been a teacher's assistant and a graduate teaching assistant when I was in undergrad and graduate school. And so teaching was something that I actually really liked doing. And doing forecaster training was a way for me to still be able to teach and have a meteorology job without being something like a professor.
Thank you. I think that's really interesting, kind of how you got there with your teaching background. I've worked with all three of you for a little bit, and I'm learning stuff in this panel, and I hope that our audience is as well. And just a reminder that you can submit questions in the questions box at any point during this panel. So David, same for you. How did you get where you are today?
After I realized that I wanted to go back to grad school and I wanted to pursue a path in weather radar, I got in touch with a senior research scientist from CIMMS, Dr. Sebastian Torres, and he was telling me about opportunities here with the Advanced Radar Research Center, which is at the University of Oklahoma. And so I didn't know anything about radar before I came here. And he said, no one really knows a lot about radar until you go to grad school. And so I applied for a master's program at the Advanced Radar Research Center. So that's when I started my my path, as a graduate student there, learning about weather radar and working with Sebastian Torres as my advisor to get my master's degree. And then after I graduated with my master's, there was an opportunity to work at CIMMS and the Advanced Radar Techniques team, like I said before, which we develop signal processing algorithms for weather radar. And I thought, yeah, that would be a great opportunity. I do want to apply all these concepts and things that I've learned in grad school. And so I applied for the position and got the job. I've been with CIMMS for a little over 5 years now.
Well, thank you. Well, and we have some questions coming in that are specific. Alyssa, this question is for you from Rachel N. She asks, do you ever get to go out in the field to work with physical instruments? And do you travel a lot to do that?
So me specifically, I don't get to work with the physical instruments. There's a lot of training that has to go into learning how to work with each individual instrument. My job is focused more on all of the instruments as a whole and the data that they collect and looking at the data that comes from them. But I still do get to travel a lot. Well, before the pandemic anyway, I got to travel a lot. We would go to, there's one meeting that we go to every year where all of the people who work on the instruments get to meet with each other and with the data quality office to discuss paths forward for how the data is going to be collected or what sorts of visualizations they might want to see in graphs that come from the instruments daily. We got to go to Tennessee. Where else have we gone? Tennessee, Oklahoma is where I'm centered, obviously. But yeah, we do get to travel a lot and it's been really fun. We got to go to Washington, D.C. last year as well.
Well, thank you. And Rachel, thank you for that question. David, this one is also from Rachel in. They ask, do you do a lot of coding in your job, or do you develop radar technologies another way?
Well, that's a good question. Well, I do a lot of coding for my job, and I think I also develop radar technologies, coding things, but these things that we're coding are, some new algorithms or techniques that we came up with. Typically, the process starts with some kind of idea or a theory. We read papers, we go to conferences, we talk to people. And so once we have an idea, maybe we write some code to do some simulation and explore and see if this idea could work. And if it works, then we dive deeper into it. And then eventually further down the road, we actually implement it in the radar because we want to make sure that this works in a practical system. And that's when we test it and validate that the theory works. So that's typically the process that I follow. It involves a lot of coding usually. I work more on the software side than in the hardware side, but I do interact a lot with the hardware myself. I don't develop the hardware though. I develop mostly software.
Well, thank you. This is going to be for all panelists, and Hannah, we'll start with you. What was the biggest challenge the panelists have had to overcome to get to where they are now professionally? This question is from Sebastian T.
I think for me, probably the biggest challenge was just getting through grad school. I loved my program and I loved my grad school, but I was also, especially towards the end when I was really trying to finish writing my thesis, I was definitely starting to get burnt out from school. And so just being able to find that motivation and drive to be able to actually finish grad school and start job hunting was probably the biggest thing for me.
Well, thank you. Excuse me. Alyssa, what about for you? What are some of the biggest challenges you have had to overcome to get to where you are professionally?
I would say for me, one of the most difficult parts was probably job hunting after grad school. It took a few years for me of trial and error with a job hunt until I was able to land in a place where the job I have feels meant for me. I've tried many different types of jobs along the way right after I graduated from grad school, everything from a professional researcher at my graduate school to a private environmental consulting firm before I found CIMMS. So I would say just don't get discouraged if things don't immediately pan out for you right after you're done with school. Sometimes it takes time.
Thank you for that advice. I know I can use that sometimes, just not to get discouraged. And David, what about yourself?
Oh, I think for me, one of the biggest things is also grad school, like Hannah was saying. In my case in particular, I completed my master's degree and then I started working for CIMMS full time. But as I started working at CIMMS, then I decided that I also wanted to stay in grad school and pursue a PhD degree. And so I've been doing that, as part-time in parallel with my full-time job at CIMMS. And that's been a little challenging. I've been in the program for a few years now. I'm actually defending my dissertation in just a few weeks, but so hopefully that will be over soon. But yeah, that at times has been challenging just to have to manage all the time, working and then working on my dissertation and doing my PhD research. It took a lot of time.
Well, thank you. So in doing that, do you have any advice? I know Alyssa mentioned not getting discouraged, and David, we'll start off with you again. Do you have any advice for those who are interested in what you're doing?
I do. I am very fortunate that I am working in a place where, my PhD research is very much in line with the missions and the goals of CIMMS and NSSL. And my advisor and supervisor allow me to work in my PhD research as part of my job, so that really helps. So I think the biggest advice that I can give to people who want to pursue a graduate degree while they're working full-time is to try to find a job that aligns well with their research interest. Something that they can use possibly for their research, for their graduate school research, and kind of double dip in that sense. Because otherwise it's very, very time consuming and it can be very challenging.
Thank you. Alyssa, same question for you.
I would say to plan to take at least a few coding classes in college if possible. It's important and useful in nearly all facets of atmospheric science, especially if you plan on going to grad school. So if you do that, it will also help you stand out when you start applying for jobs in your field.
And I think that's something with CIMMS we also recommend, and I agree, it's when people are asking us what job opportunities we have, is we say, you know, a coding class can't hurt. So thank you for that as well. And Hannah, what advice do you have?
Yeah, I definitely agree with Alyssa about try to take, even if it's just 1 or 2 coding classes, you know, just to get those basic skills. That's something I definitely wish I had been able to do in college, but the opportunity just never aligned because of class conflicts, or I was already taking too many credits or something. And it's definitely something I wish I had had the opportunity to take just to have that extra skill set. Otherwise, probably my other piece of advice would just be open if you're applying to grad schools, looking at different kinds of programs. You know, like I ended up going to a geography program. I ended up getting my master's degree in geography. And so just realizing that, you know, to maybe look just beyond what schools have meteorology or atmospheric science, just to in trying to find what grad school would best suit you. Is because that was something I didn't realize until I started applying to grad schools, is that you can look, is that geography departments often still have atmospheric science classes or programs that are under the general umbrella of geography.
Thank you for that. And that is, I think, a very good point to bring up, is that within CIMMS, we don't just have those with meteorology degrees, which I think is represented here on this panel. We have those with engineering, geography, and they don't just work in meteorology. We have social scientists, we have forecaster trainers, we have those who look at data. And I appreciate that you have other options to be involved in this field that we're very passionate about. David, this question is for you from Landon T. They ask, what sort of features does CIMMS hope to see developed in future radars? And when might this technology become available to forecasters?
Okay, wow, that's a really good question. So to put it in a functional perspective, if you will, one of the main things that we want to try to do for future radars and to help forecasters is to reduce the scan time of the data that the radar produces. So currently, the radar network produces a volume's worth of data every 4 to 6 minutes or so. And it, you know, some researchers at CIMMS have shown that giving forecasters data at a higher rate, maybe you know, one volume of data per minute or every other minute, would help them into making better decisions on what's happening. And so one thing that we're working on is trying to reduce the time the radar takes to scan the atmosphere and give data faster. Now, one thing and a challenge with that is that the current radar that we have in the country is based on parabolic reflector antennas, dish antennas. So with that technology, it's a little difficult right now to reduce that volume scan time, but we're looking into more advanced technologies like phased array radars, phased array antenna, which is a much more advanced technology that can help us reduce the scan time with much more advanced capabilities. So we're looking for a technological upgrade to help us get there.
Thank you for that. I know that there is a lot going on in your area, in your field, and it's always interesting. So thank you for answering that question. This is for all of the panelists, and Alyssa, we'll start off with you if that's okay. What is the biggest challenge in your field at the moment, in your area?
I would say trying to find productive and fast ways to gather all of the data and be able to view it in the easiest way possible, because there's data coming in from, like I said before, over 200 instruments. So just trying to gather all of that and put it together in a cohesive way is sometimes challenging, and it's always changing as well. So just staying caught up with that and making sure that you could keep an eye on all the instruments in an efficient way, I would say.
And this is kind of a follow-up question that Lisa S., and thank you for that question, to ask how much data, just to give a mind of what you're dealing with, how much data do you think you deal with maybe on a daily, weekly basis?
I don't know off the top of my head exactly. I don't want to say a guess. So I definitely can Google that though and provide the answer afterwards.
Okay, I appreciate that. And we can share that on our CIMMS Facebook page and our CIMMS Twitter page. I do know that it is quite a bit. It's more than maybe what our average user like me would say in terms of just using my computer for web browser and downloading photos and videos. It's definitely a lot more than that. And you hear these numbers and you think, oh my. Hannah, what would you say is the biggest challenge in the field at the moment?
So for, I guess, my division specifically with looking at forecaster training and trying to train forecasters to issue severe weather warnings is probably figuring out how to best issue tornado warnings for tornadoes that form in a line of storms in a QLCS, a quasi-linear convective system, which is just, a big line of storms. Just because those tornadoes can form very quickly and they can also dissipate very quickly, sometimes in between radar scans. And a lot of times those tornadoes don't always have very strong radar signatures to issue warnings on. So just figuring out techniques for issuing those warnings and how to how to best look at the radar to figure out what signatures and identify those tornadoes when they do form. Which that's definitely something a lot of people are researching and working on right now outside of just our division.
And we appreciate that. There is a question pertaining to quasi-linear convective storms and how, if CIMMS is currently researching that, we may need to follow up with that question at a later date, because as you mentioned, there is a lot of research happening with the CIMMS on that point that goes, I know, outside of our 3 areas here. If anyone wants to further discuss that research, feel free to do so now. But otherwise, we can continue to talk about, we'll move on to David and talk about the biggest challenge in the field at the moment. All right, David, we'll go with you. What is the biggest challenge in your field at the moment?
Well, I think, with these new technologies that we're looking at for the future weather radar, there are many challenges because we've never used these technologies for weather observations. Especially, for example, we use dual polarization radars. That means that we measure the hydrometeors, the raindrops, in 2 dimensions, in the horizontal and the vertical dimension. And so with the current weather radars, research on this technology, for example, has been going on for a very long time, and we understand how to calibrate our radar to get these measurements now. Now, with these new technologies, it's been very challenging for us to calibrate the radar with dual polarization to get these measurements and this data that helps forecasters, in their understanding of what's happening with the weather. So I think that's one of the major challenges we have right now is demonstrating that this new technology, the phased array technology, is good enough and even better maybe than the current operational radar to provide high quality weather radar data to our forecasters.
Thank you for that answer. We have time for about 2 or 3 more questions. The next question comes from Rachel N., and they ask, do you have any tips for picking grad schools to apply to? And if so, any tips for the application process? Hannah, we'll start with you first if you want to take a go at that one.
Yeah, so at least this is at least what strategy I used when I was researching grad schools and picking which ones to apply to. So a big thing in grad school is that generally you're always going to be doing some sort of research project in grad school. So I started with researching what universities had graduate programs in meteorology, atmospheric science, geography, earth science, kind of any of those related fields. And then I went to their website and looked to see what sort of broad research areas faculty at that university work in, to see if they sort of had any research areas that coincided with what areas of meteorology I was interested in. And so if there were, I looked to see what professors, were doing research in that area. And I would send emails to them just being like, hi, my name is Hannah Wells. I'm a senior at Valparaiso University, and I'm looking to go to graduate school next year. And, my research interests are X, Y, and Z, and just ask them, can you tell me more about your research? Can you tell me, do you anticipate taking on any new graduate students next year? And just, opening a conversation with them, just to get a feel for if I had any more interest in what research they were doing, if it was research I would be interested in doing myself. And if it was, I kept that on the list of schools to apply to.
Thank you for that. Alyssa, what about yourself?
I was actually going to mention what Hannah mentioned about reaching out to professors at different schools, and especially if you're interested in their research and sort of just feeling things out. And then also what Hannah said earlier about not just restricting yourself to the one specific major that you have in your mind. You can sort of expand it and still find areas of interest that you might like. When I was applying, I didn't know that, so I was just searching for meteorology, and I think that probably, I still ended up in a great school, but I think that probably narrowed my options just a little bit, just because I wasn't searching outside of the box.
Thank you. And David, what about you?
Well, I agree with both Alyssa and Hannah. I think it's a really good idea to contact researchers and professors ahead of time and kind of, talk about what they do and, see if your research interests are aligned with them. I also think that the personal aspect of connecting with the researcher is important. So I really like, when people are very open and very friendly and they make time to work with you as a researcher. So that's one thing that I would consider, applying for grad school. And one advice, if you're still pursuing your bachelor's degree, if you're still an undergraduate, one thing you can do is try to start working with a researcher at your university right now, and that will give you some research experience that then you can add to your resume or to your application when you're applying for grad school, and show that you have done some research. At least you started with that. So that's one thing you can do in your search for schools.
Thank you all three for that great advice, and I know I appreciate it. Hannah, this question is specifically for you. How do you incorporate meteorology and the human aspect of forecasting and weather impacts into your job and perhaps a job search?
So like in terms of like finding a job that is more of the like meteorology and sort of human side, like how did I find that job, or I guess this job?
Yes, that is what it sounds. It appears that this question is from Taylor. I'm sorry, Taylor, I did not mention that. They are finishing up their master's in geography and have a bachelor's in atmospheric science.
I guess in my job search, I didn't really do anything specific to try and like, I didn't really Google anything specific to try and find a job like this. Just in my experience of where friends and stuff ended up getting jobs after they graduated. Like I just knew CIMMS existed, and I knew that CIMMS had groups that did more of work on the social science sides. So when I was close to graduating from grad school, I definitely like kept an eye on the CIMMS job postings to see if there were any job postings that opened up that were more of the social science, kind of like human side of things. And luckily this the job that I currently have opened, the job posting opened shortly after I finished after I graduated. Otherwise, yeah, I guess the best thing would just to be to ask around to like your friends, your professors, your colleagues, just to see if they know of any job openings or if they know of any specific places that you should look for. That would probably be my best advice, would just be to, ask the people that you know to be like, hey, do you know any places that are hiring, meteorologists that are also, interested in more of the social science and human side of stuff?
Thank you for that. And if any of the questions that have been asked need to be more in depth, or if you have any follow-ups, please feel free to email us at sims@nwc.ou.edu. We have time for one more question, and this is for all the panelists, and it's from Ida. They ask, what experience solidified your commitment to pursue this field of study? Alyssa, why don't you close us out with this question?
I would say that there wasn't one specific moment or experience for me personally. It was sort of a cumulative collection of experiences that led me in this path. But unfortunately, there wasn't one life-changing experience that happened to me that made me decide this is what I want to do.
And David, what about yourself?
Well, I think for myself, I've always been passionate about electrical engineering, radars, and things like that. But one thing that really changed, and the way I see my career and solidified my path on weather radar and trying to help society by developing a technology that will be used by forecasters. One thing that changed that was when I had just moved to Oklahoma. I had been in Oklahoma maybe for like 3 or 4 months at the time. I met someone who had been impacted by a tornado. They were all safe, but their house was completely destroyed in the tornado in 2013 and more. And that was very, very sad. And so when they were telling me their story and how that really changed their lives, I thought, wow, this really affects a lot of people and it changes their life entirely. So I felt like it was really important to try to help and improve these radars and the algorithms and the techniques that we develop that ultimately end up supporting the forecasters. So that was something that made me think, okay, wow, this is really, important to help people.
Well, thank you for sharing that. Hannah, what experience solidified your commitment to pursue this field of study?
My answer is pretty similar to Alyssa's. I don't think there was any one specific moment or event that made me go, oh, this is what I want to do. It was just kind of like, obviously I'd been interested in weather from a very young age. And as I got older, I just got more and more interested in the weather. I was that person who always watched the Weather Channel and always wanted to know what the forecast was going to be. And like Storm Stories was one of my favorite TV shows. And so, when I was in high school and thinking about going to college, it was just like, well, I love weather, might as well study it and do it for a job. Yeah.
Well, I want to thank all of you for your time, and thank you everyone for attending. We appreciate it. Hannah, Alyssa, and David, thank you for your time. Thank you for sharing your advice and your stories and how you became to work here and your journey to the Cooperative Institute for Mesoscale Meteorological Studies. I know we did not get to everyone's questions today. Please email them to sims@nationalweathercenter.ou.edu. That's CIMMS at nwc.ou.edu. You can also follow us on Facebook at OU Cooperative Institute for Mesoscale Meteorological Studies and on Twitter at OU CIMMS. We'll be keeping you up to date on all of the great activities and the research that our panel is doing and conducting and how they're helping support the NOAA mission and also helping keep that data clear and good quality with the Armed Data Quality Office. Thank you again, and thank you, each of you. We appreciate your time. Goodbye, everyone, and have a good afternoon.